The universe is vanishing, slowly, silently, and far faster than anyone expected. For billions of years, galaxies have stretched into the distance, stars have lived out their brilliant lives, and cosmic structures have danced in a balance of gravity and expansion. But now, that balance is shifting. Something is accelerating the universe's demise, and we might be witnessing the final act of a grand cosmic story. The energy driving the expansion, what we call dark energy, was once thought to be steady, even eternal. But new data suggests it might be evolving, or worse, accelerating beyond our predictions. Entire galaxies are drifting away so quickly that their light will never reach us again. In the vast emptiness, the stars will vanish from sight, one by one, until only darkness remains. In this video, we'll explore the shocking data that suggests the universe is dying faster than we thought, what this means for the fate of stars and galaxies, how our night sky will change forever, and whether this could hint at a deeper, hidden force driving reality toward an invisible edge. For decades, scientists believed the universe was expanding at a steady pace, a gentle stretching of space first discovered by Edwin Hubble nearly a century ago. Galaxies were drifting apart, but the process seemed predictable, almost tranquil. Then, in the late 1990s, two independent teams of astronomers made a startling discovery. The universe's expansion wasn't slowing down. It was speeding up. This unexpected acceleration was attributed to a mysterious force dubbed dark energy, a term as cryptic as the phenomenon itself. It was as if some hidden hand was pushing the cosmos outward with increasing strength. Since then, dark energy has become one of the most profound puzzles in astrophysics, and it's responsible for nearly 70% of the entire energy content of the universe. But here's where things take a chilling turn. Recent observations from space telescopes and deep sky surveys suggest this expansion might be moving even faster than our models predict. Galaxies aren't just drifting, they're racing away, and the acceleration appears to be increasing. What caught scientists off guard were subtle shifts in light, redshifts more extreme than expected from distant type, via supernovae which act like cosmic mile markers. These explosions are some of the brightest events in the universe, and their light tells us how fast objects are moving away. But lately, their signals have hinted at something new, something unnerving. It's as if the very fabric of space-time is being pulled apart more violently than before, and we've never seen anything like it in the history of cosmology. To understand what's happening to our universe, we have to revisit how cosmic expansion works, and why this new acceleration is so alarming. Imagine the universe as a loaf of raisin bread baking in the oven. As the dough rises, the raisins, like galaxies, move farther apart. Now, imagine that heat inside the oven suddenly spikes, making the dough rise faster than ever before. That's what we're seeing. The universe is expanding, but not steadily. It's accelerating, as if someone turned up the cosmic heat. This acceleration is driven by dark energy, a force we barely understand. It doesn't clump like matter, and it doesn't behave like gravity. In fact, it does the opposite. It pushes galaxies apart. When scientists first noticed this effect using the Hubble Space Telescope and ground-based observatories, they thought dark energy might be a constant, like a quiet background hum of the universe. But more recent data, including from ESA's Euclid mission and NASA's James Webb Space Telescope, suggests the hum is growing louder and faster. Using standard candles like Type Ia supernovae, scientists compare the expected brightness of these exploding stars to what we actually observe. If they appear dimmer than expected, it means they're farther away than we thought, moving faster from us. That's exactly what researchers are finding, and it's not what our most accepted models predicted. The rate of expansion, known as the Hubble constant, seems to differ depending on how we measure it. This discrepancy is called the Hubble tension, and it's one of the biggest mysteries in astrophysics today. Some theorists believe we may be seeing the effects of a dynamic form of dark energy, something that changes over time, possibly linked to quantum fields or unknown particles. Others fear that our entire model of the universe's birth and evolution might be incomplete. Gravitational wave observatories like LIGO and Virgo are being used to detect ripples in space-time from distant cosmic collisions, and even these waves could carry clues about the universe's changing expansion. This behavior could mean we're approaching a radical phase shift in the cosmos, one that no star, planet, or galaxy will survive. Here's where things get truly mind-bending. The changes we're observing in the universe's expansion didn't just happen yesterday. They could be echoes of events that took place billions of years ago. That's because light, even traveling at 300,000 kilometers per second, takes time to reach us. When we look at distant galaxies or dying stars, we're not seeing them as they are. We're seeing them as they were, frozen in time. So when we say the universe is dying faster than expected, it's possible the most dramatic shifts already happened, and we're only just now catching up. If dark energy continues accelerating at this pace, or speeds up even more, then in a few billion years, the cosmos could enter a catastrophic phase known as the Big Rip. That's when the very fabric of space-time stretches so violently that galaxies, stars, planets, and eventually atoms themselves are torn apart. But the real question is, when will we notice something truly dramatic? The truth is, we already are. Some of the faintest, most distant galaxies captured by James Webb appear distorted or strangely dimmed, as if slipping beyond the cosmic horizon. Their light will soon become unreachable, gone forever, even from our most powerful telescopes. It's as if the universe is switching off the lights, one galaxy at a time, and when the end begins in earnest, it won't be subtle. There may be brilliant flashes, supernovae, bursts of radiation, and fading stars that glow eerily like full moons in the sky, before vanishing into the darkness. Imagine stepping outside one night and noticing something strange, an unfamiliar glow on the horizon, brighter than any star you've ever seen. It doesn't twinkle, it pulses, and it's growing. Within hours, it outshines every object in the night sky. Within days, it becomes visible even during daylight, casting shadows under the sun. This wouldn't be science fiction. It would be reality if a nearby star exploded or if a galactic event pierced the cosmic veil caused by the universe's acceleration. If the accelerating expansion triggers massive energy releases, supernovae, gamma-ray bursts, or a collapse of galactic clusters, we could witness skies alive with color. Shades of deep violet, electric blue, and burning gold could streak across the heavens as massive clouds of gas and light race outward. Telescopes would track every heartbeat of the spectacle, while people across continents would stare up, mesmerized. It would be talked about in every language, captured in every lens, a celestial firework for the ages. But it wouldn't last. In the cosmic sense, even the brightest explosion fades quickly. Days, maybe weeks. Then, silence. The glow would dim, the light would vanish, and what once lit our skies would become just another echo in space, stretched by expansion into invisibility. For us, it would be a once-in-a-civilization event, a reminder that we are passengers in a living, evolving universe, one that can dazzle us and just as quickly slip beyond our reach. What makes these cosmic events so important isn't just their beauty, it's what they leave behind. When stars explode, or when galaxies collide under the violent influence of accelerated expansion, they become cosmic forges. In these brief, high-energy moments, the universe manufactures the rarest and most valuable elements: gold, platinum, uranium. These aren't made in ordinary stars. They're born in chaos, in the pressure and heat of supernovae or neutron star mergers. Without such cataclysmic events, the universe would be rich in hydrogen and helium, and little else. Every atom of iron in your blood, every speck of gold in a wedding ring, every trace of uranium used to power a reactor, all of it came from stars like these. The death of one celestial giant seeds the birth of countless others. This is cosmic recycling at its grandest scale. It's how planets form, how life takes root. Without destruction, there can be no creation. Consider VY Canis Majoris, one of the largest stars we know, or Antares, the red heart of the Scorpius constellation. These titans are ticking clocks, waiting for their moment to collapse and give birth to something new. What we're witnessing now, this increased pace of the universe's decay, may mean these kinds of events are happening more frequently, or slipping away faster than we can observe. So when we study these explosions, we're not just looking outward, we're looking backward and inward. We're tracing our own origins in the ashes of distant stars. In a sense, watching the universe die is also watching how we were born. Despite how dramatic all of this sounds, Earth is safe. Even if a nearby star were to go supernova, or if the accelerating universe triggers wild events across the cosmos, the distances involved are so vast that we're not in any immediate danger. No gamma rays or shock waves will reach us with destructive force. What we'll see is the light show, not the impact. There may be fascinating side effects, though. A bright supernova could slightly alter our upper atmosphere, causing rare auroras or brief changes in ionization levels. But these are harmless, more of a visual gift than a threat. They'd create opportunities for scientists and skywatchers alike to witness natural beauty on a grand scale. And here's something amazing. Before the visible light of a supernova even reaches Earth, a wave of ghost-like particles called neutrinos would pass through us. Specialized detectors deep underground, like Super Kamiokande in Japan or IceCube in Antarctica, would pick them up almost instantly. This acts as an early warning system for astronomers worldwide, giving us a precious head start to turn our telescopes to the sky and watch the cosmos unfold in real time. We're witnessing the final breath of a giant, a farewell millions of years in the making, stretching across the vast tapestry of space and time. It's humbling to realize that the universe we gaze into tonight is not static or eternal. It is alive, evolving, and even fading in ways we are only beginning to understand. The stars that have guided humanity for millennia are quietly bowing out, their light fading as the cosmos itself races toward an uncertain future. Yet, within this grand ending, there is profound beauty. Every burst of light, every cosmic explosion, tells a story of creation, destruction, and rebirth. These events remind us of our own fragile place in the universe, a tiny spark of consciousness amid the vast darkness, and they challenge us to keep looking up, to stay curious, to keep exploring. Because even as the universe changes, it remains full of hidden wonders, mysteries waiting to be uncovered, stories waiting to be told. So tonight, when you step outside and look up at the stars, remember, you're witnessing a cosmic dance billions of years in the making, a story we are lucky to be part of. And who knows what marvels the next moment will bring. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. Your curiosity helps us explore the universe together.